So my name's Tom. I'm a Cambrian paleontologist and paleoenvironmental scientist just starting at University of Leicester. And I'm going to talk to you today a little bit about what we know or maybe don't know about the environment of the Cambrian Metazoan radiation. So everyone knows a little bit at least about the Cambrian explosion. We're all paleontologists here, and it's where we start to get the first real increase in diversity, particularly among the conventional, the hard part fossil record of animals. And it follows on from the much more sedentary environment of the Ediacaran period, and comes with a huge number of geochemical and environmental changes. So what do we know about the environment in the world at the moment? So there is quite a wide distribution of paleocontinents. They're very well constrained at the moment in terms of the paleogeography of the Cambrian period. These seem to be fairly robust reconstructions to new data that's been coming along recently. These haven't changed much in the last few years, at least. There have been some minor adjustments. Avalonia, which is where Britain was at this time, is marked by this star here. This is at 540 million years ago, so the start of the Cambrian period, and 490 million years ago towards the end, that we're getting into the Cambrian-Ordovician boundary there. So we've got a wide spread of continents, including some clustering right down at the South Pole, but this is generally thought to be a warm climate from geological evidence. There's very little evidence for certainly for widespread glaciation and for persistent glaciation at this time. But how warm is warm? There are very few numerical constraints on this environment, and it's this which I hope to address. So now I'm going to bring a little bit of geochemistry in, for which I apologise slightly. We have Delta 18O. There are a number of geochemical proxies for paleoclimate and paleoenvironment. One of the most widely used is this Delta 18O ratio. It's the ratio between oxygen 18 and oxygen 16, and correlates, amongst other things, very strongly with temperature. The water temperature at which something formed will influence the ratio of the oxygen isotopes that make up that substance. In particular here we're talking about shells, tests, skeletal elements of various different taxa. So this could include things like forams or mollusks, a huge variety of mollusks, and brachiopods. This has been widely used throughout the geological column and throughout geological time, really. And it's very well documented, at least, in most of the Cenozoic and the Mesozoic. There are a few gaps in here, but by taking a few different versions of oxygen isotope data, you can fill most of those gaps. This is predominantly done by forams or brachiopods and also various mollusks in this time. Moving back into the Paleozoic, things get a little bit more confusing, a little bit more complicated. We still have brachiopod calcite, the carbonate component of which gives us the Delta 18O ratio and hence the temperature. But there are quite a few more gaps, and as you can see, the data are far more spread. There's a very wide spread of these data points. Conodont elements, so these are the phosphatized parts of some of the earliest teeth, effectively, are made of phosphate, and phosphate contains oxygen, which can again give us quite a nice temperature record from oxygen isotope data. These have filled quite a few of the gaps in the Paleozoic column, but there is, as we'll see, a notable lack of this data in the Cambrian period, down here, right at the base. There are a few very spread brachiopod calcite values, but these aren't very well constrained and may well be subject to quite a bit of diagenetic alteration. That's the bit we have to assess. Conodonts in particular can't be used at this time because the euconodonts, the clade that have suitably mineralized skeletons, or suitably mineralized elements rather, for recording this isotope ratio properly and well, haven't evolved at this point. They evolve and appear in the uppermost Cambrian, but lower than that, don't really see them, or don't see them at all, in fact. So we have to look for some other repository for this data. This is where small shelly fossils come in. This is a diverse, eclectic group of, polyphyletic group of things. They're united by being small, generally shelly, though some skeletal, and and being fossils. That's the main thing that unites them all. And here we have, in Cumley, which is in Shropshire, Welsh borderlands, some very nicely preserved microfabrics. These look like they'll be well preserved enough to contain a reliable oxygen isotope ratio for the Cambrian period, and we therefore suggest that we should investigate these further for working out a temperature of Cambrian oceans. Thank you.